All right, we're still looking at limits involving infinity and asymptotes of graphs. Okay, so let's look at this next slide. Here we have a function y is equal to 1 over x, and this time, instead of looking at how the graph behaves when goes to infinity or to minus infinity, we'll look at what happens as x gets closer and closer to 0. Now remember, 0 is what makes the function y equal to 1 over x undefined. So we're looking at now one-sided limits, and it turns out that they go to plus infinity or minus infinity. So we say that the limit of 1 over x as x approaches 0 coming from the right. So I'm all getting all these values of x's coming from the right. Okay, and it says that the limit is infinity. Now, this does not mean that the limit exists, but instead that the behavior of 1 over x, remember it's a reciprocal, becomes arbitrarily large and positive as x approaches 0 coming from the right, which would just make sense. Look, if you have a 0, or rather an x that's getting very, very close to 0, like say 0.01, 0.001, 0.0001, etc., what happens to the reciprocal? Well, if you take the reciprocal of a very small number, then it becomes arbitrarily large. So say the reciprocal of the reciprocal of 0.1 is 10, the reciprocal of 0.01 is 100, the reciprocal of 0.001 is 1000, etc. So you see, as x approaches 0 coming from the right, the reciprocal becomes infinitely or becomes arbitrarily large. That's why the limit of the reciprocal, this reciprocal, as x are very, very small, that it approaches 0 positively, in the sense, because you know these are 0 coming from this, x is approaching 0 from the right, then the whole limit of this reciprocal is plus infinity. Now, what do you think is the limit of 1 over x as x approaches 0 from the left? Well, it's going to be minus infinity, because look, you're looking at all these x's that are negative and very, very close to 0, like negative 0.1, negative 0.01, negative 0.001, etc. You see that the reciprocal will become infinitely negatively large. All right? So we know then, therefore, that the limit of 1 over x as x approaches 0 coming from the left would be minus infinity. As we look at this graph, okay, your zeros, rather your x's approach 0, then the reciprocal goes to minus infinity. Also, what we can tell is that this vertical line, x equal to 0, is called a vertical asymptote because the graph will only approach it but will never cross it. So we call this one-sided infinite limits. Okay? So definition, a line x equal to a is a vertical asymptote of the graph of a function if either the limit of f of x as x approaches that a is plus or minus infinity coming from the right or coming from the left. All right, so let's look at this example. Find the limit of 1 over x minus 1 as x approaches 1 coming from the right. So the best thing to do here is just to examine what is the behavior of 1 over x. Now remember, what will make this ratio equal undefined is when x is equal to 1. So if you're approaching 1 coming from the right, that means the values of these x's are 1.1, 1.01, 1.001, etc. You see that this is just a 1 over x. If you think about it, it's a 1 over x that's shifted to the right by 1 unit. So it's the same thing. So what is the limit as x approaches 1 coming from the right? It'll be plus infinity. And as x approaches 1 coming from the left, you see this difference is going to be negative. So they will be getting closer and closer to 0 on the negative side. So it's going to be minus infinity. So let's go ahead and write that down. So as your x, so the limit, therefore, of 1 over x minus 1 as x approaches 1 coming from the right is going to be plus infinity, because remember all of these are getting closer and closer to 0 positively, so 1 over 0 positively is going to be plus infinity. Similarly, if we take the limit of 1 over x minus 1, as x approaches 1 coming from the left, then it's going to be negative infinity, because this is 1 over a number getting closer and closer to 0 in a negative sense will end up having a limit minus infinity. Okay, so we've looked at it graphically. See how it behaves as x approaches 1 from the left. The graph approaches plus infinity. As x approaches 1 coming from the left, the graph approaches minus infinity. Okay, so from the right, remember the difference between a number close to 1 minus 1 is very close to 0, but in a positive way. So 1 over 0 in a positive way is plus infinity. Then from the left, these are going to be, the differences will be negatively close to 0, so it's going to minus infinity. So we have shown it both graphically and analytically. In other words, if I don't see a graph, I can just look at the behavior. Then I can just observe without looking at the graph that this ratio is plus infinity, this ratio is going to be minus infinity. Right, now let's look at the behavior of 1 over x squared. Remember 1 over x squared is just kind of a 1 over x, but it's only, the graph is only above the x-axis because it is 1 over x squared is always positive. So as you can see here, we can look at the limit of 1 over x squared as x approaches 0 coming from the right. Okay, so I'm coming from the right. Remember, these are getting closer and closer to 0 in a positive way because they're squared. And besides, these are numbers that are close to 0, which are positive numbers. So their reciprocal would be plus infinity. Similarly, if we take 1 over x squared as x approaches 0 coming from the left, remember that these are numbers like negative 0.1, negative 0.01, negative 0.001. Then you square that, it becomes positive, positively small, then it's also plus infinity. Okay, so in both directions, you can see graphically that as I approach 0 from the left and 0 from the right, they both approach plus infinity. Okay, so now we'll be able to show that how these examples illustrate that rational functions can behave in various ways near zeros of the denominator.